Okay, so we're going to talk about how to convert a radical into simplest form or write it as a mixed radical. So what you'll typically start out with is something that looks a bit like this. So for example, root 288. So this is called an entire radical. So anytime you're simplifying an entire radical, your first step is always going to be to prime factorize the radicand underneath the radical. Okay, so prime factorization we've done before. It looks a little bit like this. So what I'm going to do first of all is take two numbers that multiply to give me 288. Okay, so it could be any two numbers. You'll eventually get the same thing anyway. So I picked these two to start. So 12 times 24 gives me 288. I notice that 12 isn't a prime number. That's why it's called prime factorization, because we're looking for prime numbers to be here. Of course, a prime number is only divisible by 1 and itself. 12 is divisible by 2, 3, 4, a whole bunch of numbers. So I can break 12 down again. Likewise, I can break 24 down. So 12 I could write as 4 times 3. Okay. I notice that 4 still isn't a prime number, so I would need to break this down again, but 3 is a prime number, so this one's fine as is. I'll stop right here with the 3. 24 I can break down into 4 and 6, and neither 4 or 6 are prime, so I continue down to the next line. So breaking down 4, of course, that's just going to be 2 and 2. I bring this 3 down. This 4 breaks down into another 2 and 2. And this 6 is, of course, 2 times 3. So now all of these down here in the bottom line are prime numbers. So instead of writing the square root of 288 now, I can rewrite it as the square root of 2 times 2 times 2 times 2 times 2 times 3 times 3. Okay? At this point, you should double check this. By multiplying these numbers together, you should get the starting one back. Okay? So what I'm going to do now, I notice that the index of this radical, it isn't shown, so it's assumed to be a 2. That means I'm looking at a square root here. So since I'm looking at a square root, I'm going to be looking for pairs of numbers underneath here. So I notice I've got 5 2's here, right? So I've got a pair of 2's right there, and then another pair of 2's right here. So what I'm going to do is I'm going to bring those out front. Each pair comes out front, okay? This 2 is going to be left over. I have a pair of 3's here, so that would come out front. Okay? So this pair of 2 comes out front. That brings in front 1, 2. This pair of 2 comes out front. That brings in front another 2. And this pair of 3's come out front. That brings me a 3. So what I've got is 2, 2, and 3 coming out front. And you can see I've got one more 2 left underneath here. Okay, so that's left right there. At this point, all I need to do is multiply these numbers here together. 2 times 2 is 4. 4 times 3, of course, is 12. So that leaves me with 12 root 2 as a final answer. Okay, so let's look at a second example now. So if we've got the square root of 160, I'll go through this one a little bit quicker. You should pause the video right now and try this one, actually. And then I'll go through the answer. That was your chance to pause. Okay. So we started by prime factorizing 160. 160 is 2 times 80. Okay, 2 I notice is a prime number because it's only divisible by 1 and 2. 80, of course, can be broken down into several things, but I used 4 and 20 here. 4 I notice can break down into 2 and 2, and 20 can break down into 5 and 4. I notice that 5 is a prime number. 4 isn't, so I break down my 4 into another pair of 2's. So right here what I've got would be 2, 2, 2, 2, 2, so 5 2's, and a 5. So that's what I write here. So the square root of 160 can be written as 5 2's multiplied together with 1 5. I take out a pairs now, right? So I've got pair of 2's here, brings 1 2 out in front. Another pair of 2's here brings another 2 out front. So I can see I've got 2 2's coming out front with this stuff left underneath. So I bring my 2 2's out front. The other 2 and the 5 are left over. Of course, now I can multiply these numbers together. 2 times 2, of course, gives me 4. And now just to write it as in final answer form here, I'm going to multiply these numbers underneath the radical together to get my final answer of 4 root 10. Okay? The process differs slightly if you've got a cube root, but not really a whole lot. So the only real difference is coming after we prime factorize here. So I'm going to quickly run through the prime factorization. So 432, you break down 854. This breaks down again and again. And this is our prime factorization here. So the cube root of 432 can be written as a cube root of 2 times 2 times 2 times 2 times 3 times 3 times 3. Now, since this is a cube root, I'm going to be looking for sets of 3 to bring out, and not pairs. So I can see here that I've got a set of 3 2's. That's going to bring 1 2 out front. And a set of 3 3's, so that's going to bring 1 3 out front. I'm going to have a 2 left over underneath the radical. So what I end up with, 2 and a 3 out front, cubed root, 2 underneath, so I can multiply this 2 and the 3 together to give me my final answer of 6 cubed root 2. Okay, so now that's the process when you're writing an entire radical as a mixed radical. So now what we're going to do is quickly cover the reverse process. So you're taking the mixed radical and you're writing it as an entire radical. So this is actually a little bit easier once you understand what happened in that process that we just did. So as an example, let's look at this guy here. So now just think about this for a second. If this 4 is out front here, when we were simplifying with the process that we just did, that must have meant that there would have been 2 4's underneath the radical. And that's why we would have brought it out front, right? So I can do the reverse process. If this 4 is out front, I can put 2 of them underneath the radical, giving me 5 times 4 times 4. And now, quite simply, I can just multiply those together to give me 80. Okay, another example really quickly here. So 3 root 6. This 3 is out front, so when I push it back underneath, I'm going to have 2 3's here. So we end up with square root 6 times 3 times 3, which of course gives me 54. Okay. Likewise, when we look at cubed roots, the same kind of deal happens. If this 2 is out here, that must have meant that there were 3 of them underneath here because it's a cubed root. So when I put it back underneath the radical, that means I've got 3 2's under here. So now I do 4 times 2 times 2 times 2 to give me my final answer of the cubed root of 32.